Hi everyone, welcome to Ethio 60. On our today's lesson, I'm going to explain how we are going to solve these questions in general. I think then I'm going to explain the way how we are going to do this problem. First of all, in order to describe this problem, you have to remember the principles or the laws of logarithm. Is that you have to know how laws of logarithms are generally or practically applicable. Is that you have to remember. Now you have to remember these laws of logarithm in general. What are the laws of logarithm? Now, the law of logarithms will be given this way. You know that the logarithm of xy to the base a is always given by logarithm of x plus logarithm of y to the base a. That this is one of the principles of the law of logarithm. That and the second properties of the law of logarithm is going to be the logarithm of x over y to the base a means the logarithm of x to the base a minus the logarithm of y to the base a. That these are very important principles. Then, and the third law of logarithm is going to be x raised to k to the base a is going to be k times the logarithm of x to the base a. That this is another law of logarithm. And the other point, the logarithm of x to the base a raised to k is going to be 1 over k times logarithm of x to the base a. This is another law of logarithm. And the fifth law of logarithm, the logarithm of 1 to the base any b is always 0. That do you know the reason? You have to know how this reason is generally delivered or not. Look, what will be the exponent of the base to have this result? Is that means b raised to 0 is always 1. Correct. And the sixth law of logarithm will be b raised to the logarithm of, for example, x to the base b is gonna be, now you can have x. Is that so? I think these are some of the laws of logarithm. Is that these are some of the laws of logarithm. These are not the only laws of logarithm. These are the basic laws of logarithm. So based on these laws of logarithm, let me show you how we are going to do this problem. Is that so? On this problem, you have given the logarithm of 2 to the, assume that log 2 to the base 10 is this one, and the logarithm of 3 to the base 10 is again x. Let's just wait. Then how we are going to describe the logarithm of 5 to the base 10? How we are going to find log 6 to the base 10 and log 15 to the base 10? How we do this one? Let me show you. Now, in order to just find the solution of this problem, first of all, let's come to what will be the solution for a. The logarithm of 5 to the base 10 is gonna be, now this is exactly 10 divided by 2. Is that so? Whenever you are interested to solve this problem, you have to look the question in different ways. Is that now your view has to be in many ways. 5 mean, now these 5 mean that is 10 over 2. So with the law of the second, now we can do this. The logarithm of 10 to the base n minus the logarithm of 2 to the base n. Is that now it is 10. This is understood. If it is necessary, you can write. If not, you can write as the professor. So the logarithm of 10 to the base n mean if the domain and the base are always the same, so the result is 1. So this is exactly 1 minus logarithm of 2 to the base n is obviously what? Y. So the result is going to be this way. That 1 minus 1. Let's come to the second problem. How could we solve this one? The logarithm of 6 mean what? this is logarithm of 2 times 3. You know that 6 can be written as a product of 2 terms, which is going to be 2 times 3. And with the law of the first, now this is given by log 2 to the base n plus the logarithm of 3 to the base n. And log 2 to the base n is what? That's absolutely y, and plus log 3 to the base n is x. So logarithm of 6 will be what? The logarithm of 6 is going to be y plus x. So this is the way. And let's come to the next. The logarithm, look, on the last problem. When you come to on the last problem, that means this one. Look, what is c mean? C mean the logarithm of 15 to the base n mean the logarithm of 3 times 5. And this is going to be logarithm of 3 plus the logarithm of 5. Is that? So what is the logarithm of 3 mean? The logarithm of 3 is obviously x. Is that? X plus what's the logarithm of 5? Logarithm of 5 is already solved here. And what is that? 1 minus y, which is x minus y plus 1 will be the logarithm of 15. Is that? So this is an easy or simple way how we are going to calculate this one. So now these laws of logarithms are really important, because you know that based on this one we can solve many problems regarding to this one. So this is the solution for the first problem. Now let's come to the second. On the second problem, what you have been looking here, what is a question and what are the points that you need to describe. So our function is exactly 2 raised x minus 1 plus 3. This is the function. Is that? You know that this is an exponential function. Is that? This is an exponential function. Maybe this is a bit quite different from an exponential function that is really given by f of x, which is a raised x. Is that? So now this is the formal definition of an exponential function. Therefore, how we are going to just describe, or how we are going to just do this one? How we are going to describe the properties of an exponential function? Let me say something about here. In order to describe the properties of any exponential problem, any exponential functions, or any logarithmic function, or any polynomial, and some other problems, first of all, you have to look how we are going to sketch the graph of this problem. Is that? If you are able to know, if you are able to sketch the graph of all these problems, then that's very simple just to describe the properties of this problem. Is that? That's the main important point that you have to know always. Is that? So as I have already shown in our previous classes, the graph of the polynomial is always being like this one, opens like this. Is that? Or opens down. Or maybe one is up and one is down. You know how to sketch the graph of this. And once you already know how to sketch the graph of this problem, it's very simple to describe the properties of every polynomial function in general. So similarly, how we are going to describe the properties of an exponential. Therefore, in order to describe the properties of this exponential problem, now the first point has to be what? We have to sketch the graph of this one. How we are going to sketch the graph of this one? In order to sketch the graph of this problem, what you have been looking is what is the x-intercept of this problem in general. X-intercept, you have to first of all find x-intercept and y-intercept. Every exponential problems have always a y-intercept, but the x-intercept may or may not be. Is that? It's maybe if this is minus, but if it is plus, every exponential function that will be written or reduced in the form of this has no any x-intercept. For example, let me say this about this one. An exponential function f of x that is going to be a raised x plus c. For c, which is positive, has no x-intercept. Is that? Now this is the general concept about how to describe the x-intercepts of an exponential problem that will be reduced in the form of this one. Mean every exponential function which is reduced or given in the form of a raised x plus c for any c which is absolutely positive, maybe zero also, greater than or equal to zero. For any c that is greater or equal to this has no any y-intercept. I mean no x-intercept. Has no x-intercept mean what? What does it mean? Has no x-intercept. The graph of this function never crosses the x-axis. Is that? The graph of this function never crosses the x-axis. And moreover, now from here, what you're going to understand, when you sketch the graph of this problem, the graph of this problem have a horizontal asymptote, which is y is equal to c. And y is equal to c is the horizontal asymptote for the graph of this problem. Now you know that since c is positive and since c is positive or maybe zero, now the graph of this problem is gonna be c. Well, if c is zero, now the graph of this problem maybe like this way or maybe like this way. That if c is exactly zero, the graph of this problem is gonna be either this way or this way. Depends on the coefficient for a. You know that this will be a raised x for a is absolutely greater than 1. Now that is in between 0 and a is less than 1. And this is gonna be a raised x for a greater than 1. Is that? And you know that in the case of this problem, if this is the x-axis, now you know c is already 0. C for both is 0. Is that? C is for both is 0. And the second way of the graph of this problem is going to be what? You know that the graph of every exponential function is going to be like this way. Is that? Graph of any exponential function is going to be like this way. You know this is the graph. Because the graph of every exponential function will be either this way or this way. Is that? Because the asymptote for an exponential function for c that is 0 is going to be the x-axis or y is equal to 0. So it will be like this or it will be like this one. Depends on the base of an exponential functions in general. So without just using any table of value, the graph of any exponential problem is going to be this way if c is 0. Is that? F is 0. So this is how to sketch the graph of this problem. When you come to the second problem, if c is non-zero, the graph of this problem is going to be, this is the x-axis and now this is the y-axis. And c is going to be like this way. That? And depends on the value for a. If a is greater than 1, now the graph is going to be like this way. That? If a is absolutely between 0 and 1, the graph is going to be like this way. That? So this is how we are going to sketch the graph of an exponential function whose base is greater than 1 and between 0 and 1 for any c that is different from 0. And here c is different from 0. Is that? That means if the value for c is slightly different from 0, now the horizontal line y is equal to c will be a horizontal asymptote for the graph of this function. So and hence, now let's come to the given problem. How we are going to describe the properties of this problem. Now from here, I have already explained with the general case. So in the case of this problem, look how I'm going to explain the properties of this one. Is that? So from here, what is given here? Now this implies that y is going to be 2 raised x minus 1 plus 3. That here, now this implies that c is obviously 3, which is positive, and a is obviously 2, which is greater than 1. That here, what you have been looking, what's the base of this exponential? Having the variable 2, that is greater than 1, and what is the constant that is added on this one? That's 3, which is positive, greater than 0. And then you know that from these two, now this implies that y which is equal to c that is 3 is horizontal asymptote for the graph. Is that? This is a horizontal asymptote for the graph of this problem. And the graph of this is obviously will be for the second case this one. But before that, we need to determine this problem. This problem has no what? Has no x-intercept. Is that? Because I have explained before. Every exponential problem that will be reduced in the form of this one for anything which is greater than or equal to 0 has no x-intercept. Because of that, no x-intercept. Even I can show how the x-intercept of this problem doesn't exist. Is that? Even you can show. That's the point. And the other point, what's the y-intercept? In order to determine the y-intercept, you have to give x0. So y-intercept is going to be 2 raised 0 minus 1 plus 3, which is going to be 2 raised minus 1 plus 3, which is 1 over 2 plus 3. That is going to be what? That's perfectly what? 7 over 2. Is that? 7 over 2 will be what? This is the y-intercept. And hence, now the graph of this problem is going to be, the graph of this problem is absolutely y is equal to 3, c mean this is assumed to be y which is equal to what? 3. And the y-intercept is going to be 0, 7, that is 3.5 mean around here. And the graph since the base is greater than, since the base of this exponential function is absolutely greater than, now this is greater than 1, so the graph is going to be this one. Is that? So how we are going to manipulate the properties of this one? Now the first property for this problem, domain is real. Is that? Domain is what? Domain is real number. Is that? Any real number can be the domain. And the range of this problem is going to be what? What's the range of this one? For any real number, now the range is going to be y is greater than 3. That? This is our range. Range is completely above 3. That? Above the horizontal asymptote. So the range of this problem is going to be above the horizontal asymptote. That is y greater than 3. And now the other, no x-intercept, no x-intercept, and for y-intercept is going to be what? 0.7 over 3. And the other property of this problem will be what? The horizontal asymptote is obviously y is equal to 3 is horizontal asymptote. Is that? Y is equal to 3 is a horizontal asymptote. And the last point is going to be y is an increasing function. Is that? An increasing function. It's increasing. Is that? It's increasing function. Is that? Now the function is absolutely increasing. So now these are the main properties of this function. Is that? Always, whenever you have any problem, any function, any exponential problem, that will be given in the form of this one without any table of values or without any just calculating the value for this problem. If you know the general concept about this one, you can sketch, you can draw, you can describe the properties of any exponential problem. So these are the basic exponential function property that you have to look, that you have to understand from this problem. So if you are again a new member of my YouTube channel, please share, subscribe and like Ethio 16. And please, you'll never lose if you subscribe and share Ethio 16 for any other source. So thank you for today. Thank you for watching. Bye bye. I'll come with another lesson for the next period. Thank you.